Okay, I'm recording now. Okay, so I have to add all البتاع الكومبوننت in the system. Okay. فشنو عندي؟ عندي طبعا أول شيء الميثين اللي هو الرياكتنت. اوكي، فأنا عندي الميثين ميثين. Okay, I'm adding it. ما راح. Sorry, that's the methane. Add it. Make sure it's been added. Then عندي carbon monoxide, carbon monoxide, mono أقوى. Okay, add it. Make sure it's been added. بعدين عندي hydrogen. عندي hydrogen. We have to make sure it's also added. وعندي carbon dioxide أقوى. We have to add it. وبعدين عندي water. Okay, and it's been added. عندي 5 component 1 2 3 4 5. H2O already موجود هني. So I have 5 component available here. Next, we go to the fluid package, and I'm going to select Ping Robinson as well as our thermodynamics package. الخطوة الثالثة إذا عندي تفاعل I go to the reaction and I add both reaction. Okay, so I'm going to add reaction and then add reaction. It's a convergent reaction. بقول له add reaction. سكة. Double click on this and I will add the first reaction, which I have methane and I have water. I have carbon monoxide and I have hydrogen. And the stoichiometric coefficient is -1, 1, 1, 3. Okay. في شيء غلط. Yeah, that's -1. لازم شباب هاي يكون 0. Okay. طبعا مثل ما قلت لكم أعطيتكم الconversion factor, sorry, conversion مال الميثين and it is 87. Okay. Now you can see it's a green, but still the standard heat of reaction has not been calculated because no thermodynamics package has been attached. So I have to add this thermodynamics package. ابتدي التفاعل الأول دخلته. Okay, so I have one active reactions here. So I need to add the other reaction. Okay, so we add reaction, another conversion reaction. أصكه. I need double click عليه وأدخل التفاعل الثاني اللي هو methane. And then I have water, and then I have carbon dioxide, and then I have hydrogen. فبصير عندي -1, -2, 1, 4. Make sure it's 0, and then I add the conversion factor, sorry, the conversion as 13%. طبعا يا شباب لاحظوا أنا دخلت المعادلات وما تحكيت عن سالفة independent reaction and dependent reactions, okay? But remember that I'm introducing the stoichiometric coefficient, so somehow in the background, a matrix is created. A matrix is created at which بيكون في matrix ورا في background يحتوي على 2 rows و 5 columns. بيسمون عليه reduced row echelon form, kind of. وبيجي يكون إذا المعادلات independent أو لا. إذا هم مو independent, they will treat it in the background. So we don't have to worry about this. Okay? Okay. So طبعا لاحظوا على طول the reaction هني added because I have already added the thermodynamics package. So now the two reaction has been defined. And now I can move to the simulation. So we have our feed. طبعا مثل ما انتم تشوفون في الرسمة يعني الفيد عندنا ميثين وعندنا water. Okay, so we have basically two streams. So طيب شباب sorry the feed here, as you can see, dash and temperature 600 Kelvin. Okay, let's call this stream the methane. Okay, that's the CH4. درجة حرارة الستريم 600 Kelvin. ضغطه 1 atmosphere. And the molar flow rate molar 100. Okay, so the molar flow rate is 100 kilogram mole per hour. And it's a pure methane. Only one methane and everything else is zeros. Okay, and you'll see that the stream is already converged. الستريم الثاني شباب عندي ستريم ثاني هو الهيدروجين. Okay, so sorry مو الهيدروجين الماء. Okay, the steam basically. That's the steam. Stream الستيم وداش على نفس درجة الحرارة 600 Kelvin 600 Kelvin 1 atmosphere and the molar flow rate. طبعا هني إذا تقرأ the problem statement they have give us the relation. So we have 2 mole steam for every 1 mole of methane. So basically the molar flow rate is double that. It's 200 kilogram added 200 kilogram mole per hour. And this is the pure water. So we have one here and everywhere else is 0. Okay. So the stream converges well. Then we have a conversion reactor. No, sorry, not the separator. We have a conversion reactor. Added. So to do, if the reactant are supplying the ratio of 2 mole and heat is supplied to the reactor to produce and is completely converted. Any question? Yeah, that's at the Q, right? In the reactor. We're coming now. Q is this is a Q. This is heat. Okay, I understand your question now. So okay, من اللي سأل السؤال؟ I don't know. واحد كتب السؤال وشاله. No problem. This is actually على الدود هنا عاد. No problem, Ali. Okay, this is the Q شباب. This is not O. Q اللي هو الهيت. The heat is which is exchanged with the environment. طيب الحين شباب هني بدش عندنا two stream ادخلهم الاثنين. So الستيم والميثين as you can see. وعندي هنا طبعا الرياكتور بيطلع منه فوق vapor وتحت liquid. And as شباب التفاعل شباب مال الرياكتورز الكونفرجن رياكتورز in Aspen HYSYS by default is an adiabatic reactor. يعني لا يسمح اذا انت فاضي هو راح يعتبره adiabatic. يعني غير مسموح للheat to be exchanged with the environment between the reactor and the environment. اول ما تحط لك QR هني خلاص يفهم انه هو مو adiabatic. It is not adiabatic and the heat will be exchanged. Heat will be exchanged either heat added or heat removed. Depend طبعا على انت ايش تبي. Depend على انت شنو تبي في تحديد درجة الحرارة مالتك الاوتلت. ففي السؤال شباب قال لنا ان the product has a temperature of 1300 كلفن. اوكي. انت بتشوف انه عقب شوي بيطلب درجة الحرارة بس قبل الحرارة مكتوب require a reaction set. معناته هايسس يبي يعرف شنو التفاعلات اللي قاعدة تصير داخل الرياكتور اللي هم التفاعلين ذري. فأنا عندي set 1. set 1 طبعا لا تنسى في تفاعلين تشوفهم داخل set 1 في تفاعلين. طبعا ليش عندنا فكرة الست؟ ليش عندنا فكرة الرياكشن set؟ لأن شباب لما يكون عندك فلو شيت فيها أكثر من رياكتور ساعات يكون عندك أنت الفلو شيت مالتك أصلا فيها أكثر من رياكتور وكل رياكتور فيه تفاعلات مختلفة. لذلك جاءت فكرة الرياكشن set بحيث أن أنت تحط كل التفاعلات اللي تخص كل reactor in one set. So you package it. So this is like a different package. Okay. فهاي التفاعلات this is like two reaction that goes inside this reaction set. Okay. فأنا بقول له add اللي هو الرياكشن set مثل ما انتم شايفين هذا الرياكشن الأول وهذه conversion ماله 87%. اوكي وهذه عندي الرياكشن الثاني وهذه conversion ماله 13%. اوكي جود. اخر شيء بقى لي unknown duty. unknown duty ليش؟ معناته يقول لي انا I cannot calculate your QR. You didn't tell me you want me to calculate QR based on what? So I'm telling him I want you to calculate for me a QR such that the outlet temperature of the V stream will be لأن هذه vapor it's a gas phase reaction. Okay. فأنا بدرجة حرارة الفيبر تكون 1300 كلفن. مجرد ما أقول له كذي المسألة انحلت. ففي السؤال شنو طالب مني؟ السؤال طالب مني he want me to calculate the outlet composition and the Q. So basically right click and add for him the workbook. أنا عندي الماتيريال stream as you can see تحت. Okay, so that's the material stream and right click again you will get the composition اللي طالبه رقم 2 and of course الheat طلبها منه so you add the energy stream and you get the Q and that's complete the problem. طبعا لاحظ شباب هني الكومبوزيشن لاحظ الميثين طبعا 0. Well, you can see there is a liquid stream here, but this number doesn't have any sense. لأن الفلو مال الليكويد, look at the molar flow مال الليكويد. The molar flow of the liquid is by itself, it's 0. Okay, so the molar flow here is 0 liquid. Okay, فمعناته أي شيء هنا ينضرب في ذي, which is 0. So this doesn't have any sense. It is just there because of the يعني template creation اللي صار. Like, and this is what is important. So this is the composition of the outlet. Okay, you can see that the methane is 0. It's completely converted. It's completely converted. And that is the heat needed to be added to the system. Okay, شباب, any question regarding this? Any question, شباب, regarding this problem? Clear, very good. So far, so good. So far, no clear. Okay. What is Nariman not clear? اوكي. شكرا علي. انا ما فهمت ايش قصده. Good. So you guys understand your own language, huh? Okay. طيب شباب, لو انا ما كنت اعطيتك الconversion reaction. If I don't give you the conversion reactor, how are you going to solve this problem? يعني السؤال من غير الconversion مال كل reaction ينحل. Well, before I proceed even further, can you please calculate for me the degree of freedom for this problem? Can you guys? I'll give you 1 minute to calculate the degree of freedom for this problem like what we did before. 1 minute. يلا بسرعة, اللي حاصلة يقط لي الجواب في الشات. Y is -1. Just ignore the Q. ما أريد أنت دخلت الQ في السالفة. Just ignore the Q. It's a 0. Yeah, it's a 0, شباب. It's a 0. So it means that this problem is solvable. Okay, كاو شباب. Degree of freedom, as you can see here, the number of stream variable is 6 plus 2. The reaction, the number of independent composition عندنا 1, which is this guy. Okay, number of independent relation عندنا هذه ratio. And معطينا في السؤال basis of the degree of freedom is 0. This is the degree of freedom for the material balance. Okay. والسؤال ينحل. السؤال شباب ينحل manual بال AX equal B, and you can solve the problem, and you have seen that HYSYS give us the solution of this problem. Okay. طبعا أنا عقب ما أنت تحل السؤال manually, you will be able to calculate the conversion of the two problems. Okay, the conversion of the حق التو reaction. لكن لو انا مثلا ابي احل السؤال بالهايسس, انا ما بيكون عندي الكونفرجن, لان انا ما بحسب المساله manual. So I want to solve it without calculating the conversion. Before I tell you how to do this, I want to talk about two utilities مهمين موجودين في الهايسس. Okay, اسمهم الset والspreadsheet. They are very useful tool موجودين في الهايسس, ومن تعلمهم دايركت عن طريق problem. So I have a problem here شباب. عندي هني سؤال. I'll give you 1 minute to read it. Okay. الهدف من السؤال دي شباب, أبي أعرفكم على two utility موجودة في الهايسس. تو يوتيليتي موجودة في الهايسس، واحدة منهم اسمها السبريد شيت هذه، واحدة منهم اسمها الادجست ينبع. اوكي، فبعلمك اياهم عن طريق example. Okay, through the example you will know what they are doing. طيب, for this let's give you 1 minute to read the question. Okay, Shabab, so in this problem we have a stream. Let me draw it for you here quickly so you have a feeling how the problem look like. Okay, عندنا شباب stream. اوكي, عندنا ستريم شباب يحتوي على الهيدروجين والايثيلين والميثين والايثين. طبعا ايثيلين يعني دبل بوند، ميثين سنجل بوند، ايثين سنجل بوند، وهيدروجين. هذين شباب المفروض under this condition هم بيكونوا في الفيبر phase. Okay, very low temperature, sorry, very low temperature and very high pressure. نبي ندخلهم على كولر شباب، نبي ندخلهم على كولر. ليش؟ لأن ذلين شباب لما أنت تبرد، أوكي، لما أنت تبرد يعني أبي يصير عندي two phase vapor و liquid. أوكي، أبي يصير عندي two phase vapor و liquid بحيث إني أنا بفصل، بخلي الهيدروجين فوق، mainly هيدروجين فوق، وهذه اللي هو بنسميه separated stream, separated from hydrogen, separated stream أو البوتوم stream. أوكي. ففي السؤال هذه شباب معطينا طبعا الكومبوزيشن ومعطينا المولر فلو ريت والبريشر، لكن مو معطيني الكيو، مو معطيني الكيو ولا معطيني التمبريتشر اللي بتطلع. اوكي، مو معطيني الكيو neither the temperature اللي بتطلع، لكن اعطاني some specification. اوكي، قال لي هني ابي الايثيلين اللي بيطلع في الهيدروجين ستريم يكون less than 2%، يعني يبي يكون هني أقل من أو يساوي 2% من الإيثيلين. because this is a separator بيكون عندي هيدروجين إيثيلين ميثين وإيثين فوق، وأيضا بيكون عندك هيدروجين وإيثيلين وميثين وإيثيلين وإيثين in the bottom as well. فلاحظ السؤال دي شباب بيكون فيه إنك أنت تحاول تضبط الكيو. I want to adjust the Q such that أحصل 2% هذه. And here where we have this very useful block اسمها adjust، تسوي لنا الشغلة دي. اللي يستخدم اكسل بيلاحظ انها يتشابه الجول سيك اللي استخدم قبل اكسل، بيحس ان adjust هي kind of the goal seek. And guess what the adjusters do? It's basically solve root finding problem. It solve a root finding problem. Okay, فبتشوف basically, well, let's see it and then you can imagine how it looks like a root finding problem. طيب, now let's go to HYSYS and let's start a new case. So file, a new case. Now, let's look at the component list. So we have to add this 4 component here that we have. عندنا hydrogen أكوى وعندنا hydrogen وعندنا ethylene وهنا أكوى C2H4 ethylene, yeah. Okay. طبعا if you don't find it ethylene, you can write it as a ethene. Okay, بعد ethene from your organic chemistry course. بس أنا طبعا اختاريته. يعني إذا أنا I remove it from here, if I remove it from here, okay. إذا كتبت ethene, okay, لأن ethene هي ethylene. Okay, so the full name you may find it as ethene. You write it again. Ethene, which is here. So the full name is ethene. The formula is C2H4, and the simulation name is ethylene. فأنت بتلاحظ هذين الثلاثة كاتيجوري هني. فإذا أنت بتدخل المركب بس بالفورمولا بالكيميكال فورمولا تختار فورمولا. إذا أنت تعرف الفول نيم ماله أو السينونيم بتسميه مثله اللي هو في هالحالة ايثين. السيميوليشن نيم يسمونه ايثيلين. اوكي، عشان شي انا دائما اروح بالفول نيم احسن. اوكي، لكن both are اوكي، كلهم are اوكي، كلهم نفس المركب. تمام، هذه الايثيلين وعندك بعدين الميثين. هالمره نروح بالكيميكال فورمولا، نغير شوي. اوكي، بالكيميكال فورمولا بقول له اعطني CH4. اوكي، بالCH4 بتشوف عندك الميثين. اوكي، لاحظ السيميوليشن نيم شباب، لاحظ السيميوليشن نيم مختلف. اوكي، شوف عندك انك المارش gas or whatever. Okay, but now we want the methane, so we will add it. واخر component عندنا هو الإيثين. اوكي، الإيثين. خلينا مرة ثانية على الفول name, which is I prefer, and then we will have the ethene, which is a single bond. This is alkane. فهم هذين الأربعة component اللي عندي. لأن مثل يعني ساعات يكتب بطريقة مختلفة، but don't worry about this. أنت بس اكتب إيثين مثل ما هو مكتوب لك في problem statement. Write it as it is, and don't worry. And what you will find it just one. يعني for some reasons في اختلافات خفيفة، بس it's an advanced differences that you don't have to be aware or worry about at this stage. Don't forget, here we now give you like an introduction course to HYSYS. فلا تدققون في التفاصيل اللي هي محتاجة واحد يكون شوي عنده advanced knowledge of HYSYS. اوكي، احنا هني الهدف مالنا ان احنا نعرف المين شلون what are the main objects and procedure موجود في HYSYS. مجرد ما يصير عندك هذه خلاص موجود، تبتدي تدور في التفاصيل اكثر. لكن تشغل نفسك بالتفاصيل وانت الحين ما تعرف البيسك، غلط، لانك ولا بتفهم البيسك ولا بتلاحق على التفاصيل. اوكي شباب، فركزوا على البروسيجر البيسك. يعني حتى even the thing that I'm doing it can be done in a different ways. But أنا مو مركز وايد إن أنا مثلا I'll give you an example. أنت for example أنا أول ما أدخل الكومبوننت I haven't told you before that if you double click on this you might find some properties of the material. Okay, يعني مثلا أنت الحين لما دخلت الكومبوننت تبي تعرف النورمال boiling point. It's given to you here, see? But I didn't go to these details لأني ما أبي أشغلك. فأنا مثلا باي هني وبقعد أشرح أنت عبالك النهاية. For some reason it's an important point. وفي هني properties. So these actually look like an appendix from your thermal or 111 book. You have information معطيك إياني. And يعني مثلا I want تعرف the boiling point مال الأربعة component. I can know this. So high minus 88. Okay. Well, this is very important عشان نعرف whiches will go to the top. Okay. فتلاحظ إن normal boiling point هذه أقل واحد minus 252.6 normal boiling point. The hydrogen. الإيثين minus 88.6. الميثين كم؟ minus 161 والإيثيلين is minus 103. فلاحظ شباب الهيدروجين أصغر رقم فيهم minus 252. So في السيبريتر I can expect إن الحبيب هو اللي بيكون في التوب. Okay. Now this is the kind شكرا الله اللي أقول لك أنا ما أبي أركز وايد الحين في التفاصيل أنا I leave this for you to explore it later. أنا الحين مركز على المين steps اللي تخليك تقدر تستخدم HYSYS. And I know that these things you will get it later. طيب نرجع مرة ثانية. You have the 4 component دخلناهم بعدين نروح على ال fluid package بندخل ال Ping Robinson convert ما عندي reaction so I go to the simulation. So now I have this stream here. Oops, what I did here. Also simulation. ماذا حدث؟ Okay, I don't want the strip chart. Simulation. طيب, and then a material stream شباب, and inside the material stream what do we have? We have أعطانا طبعا الفلو ريت ماله شباب أعطانا temperature minus 50. So the temperature of this stream minus 50 degrees Celsius. الضغط عندنا 20 بار عندنا 20 بار وعندنا المولر flow rate 1000 kilogram mole per hour. Okay, and this is our feed stream. Okay, so we'll call it feed. وعندنا الكومبوزيشن مثل ما معطينا في السؤال 0.55 0.25 الإيثيلين لا سوري الإيثيلين 0.25 yeah الإيثين 0.1 والميثين 0.1 عدد شباب الهيدروجين 0.55 الإيثيلين 0.25 الإيثين 0.1 والميثين 0.1 yes okay so the stream converge and at this condition you can see that the stream is a vapor phase. At this condition the stream is a vapor phase. معناته شباب لما أنا أبرد المفروض اللي لهم boiling point the one who has a boiling point عالية okay يبتدي يصير لهم condensation. صح ولا غلط؟ صح ولا أنا غلطان شباب؟ Does that make sense to everyone? Does that make sense to everyone? ولا لا؟ Okay, the stream لهم different boiling point as you have seen. They have a different boiling points. Okay. فكانت lowest boiling points كانت حق الهيدروجين. فهو كان هو الأخف بينهم. متوقع أنه هو الأخف بينهم because إيثيلين إيثين ميثين أصلاً هم يحتوون على الهيدروجين صح؟ يعني هذه CH4 هذه C2H4 هذه C2H6 فالهيدروجين already part of these فهو kind of أخف منهم. Okay. ففي هم أثقل ففي عملية التبريد هم they might condense. Okay, تمام. Then that's the feed and we want to cool it فمحتاج cooler اوكي. طبعا شباب الكولر انا الحين ما اعرف يعني اوكي that's the inlet feed and this is cooler out that's a cooler out وفي energy to be removed I'll call it QC هذه انا ابي اشيلها لان هذه cooler. طيب عشان ما عندي temperature I don't have the temperature of the outlet stream. Since I don't have the temperature so I don't have the درجة الحرارة so that عشان يصير عندي طبعا هذه cooler فأنا ممكن أحط 5 لأنه قال لي unknown delta P ففي البارامتر I can put 5 PSI مثل ما قلت لكم أو حتى صفر ما بتفرق أوكي فبقول له 0 أو خلينا نعم احنا متفقين كلها 5 PSI let's put it 5 PSI اوكي في البريشر شباب sorry let's go to the condition the temperature the outlet temperature انا ما عندي اوكي وبالتالي عشان اخلي الستريم يصير converge بقول له QC 0 يعني ما صار عندي any heat exchange فبتشوفها حسب التمبريتشر because you either give him this or this وعادة احنا يكون عندنا ذي في الأسئلة in the previous question we do have this and he calculate for us this الحين أنا عكست السؤال فأعطيته ذي so he was able to calculate this and since the QC is 0 no heat exchange happened فبتشوف درجة حرارة الفيد to the cooler and the cooler out are the same so nothing happened. Why I did that? Because I have no information and I want force the cooler to be solved. لكن لاحظ الكولينج ذي will not give me what I need. Okay? فإذا أنا قلت له الإنلت حق السيبريتر is cooler out وعندي فوق well let's call this the hydrogen stream. The hydrogen stream. هل نسميه the vapor hydrogen stream لأنه فوق vapor وتحت بنسميه the liquid separated stream. Okay. Now you can see السؤال انحل لكن 100% لم يعطينا does not give us what we are looking for. Okay. The question is solved but it doesn't definitely give us what we are looking for. And someone might ask what you are looking for. Well, I'm looking for the following. I want to make if that's correct, it means that we want the ethylene present in the hydrogen should be less than or equal to 2%. فانتبهتي هني في الستريم. اوكي اول شيء لاحظ شباب انت عندك هني 1000 molar kilogram mole per hour and here we have 0 kilogram per hour. What does that mean? It means that ما صار عندي separation because everything goes to the vapor phase. For you to have a separation لازم يصير عندك at least 2 phase. Let me ask you a question شباب. Can I have a separation with just a single phase? شباب, can I have a separation where I have a single phase? Yes, no? Can you give me an example? Can I have a separation with a single phase? شلون يعني يصير عندي separation وانا عندي single phase? Okay, I think so. It's phase already. So why I want to separate it? Okay, okay. تخيلي الفيز هذه نرمان يحتوي على مركبين. إذا هما في vapor phase, it means that they are together. They are not separated because they are in the same phase. Okay, they are in the same phase. أعطيك مثال ثاني. لو أنا عندي ماء وملح. اوكي it's a solution، يعني انا باخذ الماي بحوس الملح اللي فيه لين ما يصير solution. اوكي اللي هاليوم الناس تمضمض فيه تغسل خشومها بسبتها الجو الجميل، فتشوفون المزكمين مثلي. اوكي الماي وملح، فانت تسوين لك ماي تحطين فيه ملح and you mix it very well to become a solution. Can I go back and separate them while they are in one phase? Okay, can I separate them while they're in one phase? Okay, شلون نريمان؟ Just heat it. Okay, when you heat it, what happens? Vaporize. Okay, and then what you will get? You will get what? How many phase? Salt only, which is what is the phase of the salt? It's a solid. It's a solid and gas، صح؟ فبيصير عندك vapor وعندك solid. شباب عشان يصير عندك separation تحتاج at least two phase. I cannot think of a separation with one single phase unless you guys can tell me. Okay? Unless you guys can tell me how can we separate. طبعا شباب كلمة phase. Yes sir.
دكتور liquid extraction يعتبر separation؟
liquid extraction يعتبر separation نعم.
وعادي إن يكون two phase one phase يحصل separation.
صح. You're right. I will give you an example similar to the one that you have mentioned, but there is one thing ناقص في الصورة اللي تتكلم عنها. لما يكون عندك الاويل اللي يطلع من الابار البترول لما يحطونه، اوكي، فبتشوف عندك تحت، طلعنا عن الموضوع شوية لكن يسوى، وين الكالر؟ بتشوف دائما عندك تحت ماي، طبعا وهو جاي في البيب، وهو جاي في البايبس قبل ما يدش الثري، شيء يسمونه 3 phase separator. ان شاء الله اللي فيكم بيروح يشتغل في تطوير بيشوفه 3 phase separator. ايش مكتوب يا من اللي تحت كم ساعة؟ مين آخر واحد تكلم على liquid extraction؟
حازم.
من؟ حازم. أيوة يا حازم. 3 phase separator. اسمه إيه؟ 3 phase separator. لو طليت داخل حازم بتشوف 3 phase separator هذه تحت مية water. او قبل ما اقول لك شنو هاي البئر النفط اللي الاويل اللي يطلع منه شباب يمشي في البايب، يمشي داخل البايب، عبارة عن 3 phase system، 3 phase fluid if you like. اوكي، لكن هذا ال 3 يحتوي على ثلاثة اشياء، يحتوي على اويل ويحتوي على ماء ويحتوي على غاز. تقوم تدخله 3 phase separator، فبتشوف تحت عندك اويل ووتر، وفوق عندك اللي لونه اسود، فتتوقعون يكون شنو؟ تتوقعون شنو يكون الاسود؟ اويل بالضبط. وفوق عندي شنو؟ شوفوا لونه اسود. اوكي طيب، ده اسمه حازم غاز، وده اسمه اويل، وده اسمه ووتر. طيب ليه بقى هم مسمينه 3 فيز وهم الاثنين دول حسب ما احنا فاهمين في الفيزياء مالت المدرسة الاثنين ليكويد؟ طب هم مسمينه 3 فيز ليه؟ تقدر تقول لي حازم؟ جس حتى لو الجواب مو صحيح.
لأن الووتر والأويل insoluble يعني بيختلطوش ببعض، ففي باوندري، كان في باوندري between the oil and the water and gas and oil.
تمام. They have different viscosity. they have different properties. لا هو في كلمة ما حد يابها لي الحين، هم لهم حاجة خلتهم ينفصلون عن بعض. Okay, they are not mixing, they are immiscible. They are immiscible. Okay, but what makes them like this? They have a different. Thank you very much, Saud al-Dosiri. That's the word I'm looking for. They have different densities. They have different densities. Okay? فهم أيوة هم الاثنين صح كلامك، هم الاثنين two liquid، لكن تم الفصل بينهم. تم الفصل بينهم. Okay? And إيه اللي خلاهم ينفصلوا؟ Because they have a different density. طب سؤال، can they be mixed? Yes, they can. They can mix by the way. وهو عندنا في حقل البحرين، حقل البحرين ما لنا حقل قديم. In fact they are mixed، ولما يتمكسوا ببعض لهم اسم يسمونه emulsion. بيسموه emulsion. تعرفون شنو الemulsion؟ العسكريم اللي تاكلونه الايس كريم is emulsion. اوكي؟ الايس كريم emulsion. الكريم اللي يستخدمونه البنات emulsion. It's an emulsion. Okay? So you can de-emulsify this and make it into two phase. So this is a three phase. الغاز. طيب وهل الغاز ممكن يكون مع الاويل؟ Yes. اعطيكم اسهل مثال للغاز مع الاويل. البيبسي كان. سوري، الغاز مع الليكويد. لما يكون عندك الكان مقفولة مسكوكة، الغاز وين موجود؟ موجود في الليكويد. Are they separated? No, they are together. They are together. فأنت شنو سويت لما تفتح البيبسي when you open it? You reduce the pressure. You reduce the pressure. And that's what actually happened in the three-phase separator. They reduce the pressure فالغاز يبتدي يشرد كأنه علبة كوكاكولا أو بيبسي. فأنت لما تفتح علبة البيبسي ولا الكوكاكولا أو الصودا whatever، شنو يصير؟ You reduce the pressure. So what happened? The dissolved CO2 يصير له escape. هاي CO2 ترى. The dissolved carbon dioxide يبتدي يهرب، اللي هو تس اللي تسمعها القوية ذي. يبتدي هاي كله يطلع من الليكويد. So what happened؟ ليش طلع؟ اوكي، أو لما طلع you reduce the pressure، صار عندك two phase and the vapor or the gas or the CO2 molecules left the liquid phase. Okay, so you need multiple. عشان شي يسمونها three phase even though they are liquid and water. And why they are different phase? Because they have different properties. Mainly they have different density. ومثل ما انت شايف لأن الماء تحت فأكيد الدنسيتي مال الووتر أكبر أثقل من الدنسيتي of the oil. أوكي، طلعتونا من السالفة، لكن نرجع مرة ثانية. شنو كنت أقول هني أنا؟ أوكي. أنا كنت أقول إن the stream here we have a water, we have the whole flow rate. شوفوا 1000 كيلوغرام مول per hour is a hydrogen وهني عندي zero، فما صار عندي عملية فصل. Another reason you can see the composition. The composition is 0.55, 0.1, 0.1, 0.25. Look here, when you double click and go to the composition, it's the same. لم يحدث عملية فصل. فهاي كنا ما له معنى. هاي كل اللي دشني راح فوق. Okay. So what I want to do، أنا إذا غيرت الكيو هذه، if this Q will change، okay, if this the Q will change، أنا بيبتدي يصير عندي عملية فصل. ليش؟ لأن I will start to condense those heavy components اللي موجودين اللي هم الإيثيلين والإيثين. Once I start to cool the system, they will start to condense. طيب خلنا نسوي الشغلة ذي manually. يعني لو أنا خليت الكيو مثلا هني مثلا equal I don't know like 2000. اوكي، طبعا 2000 قليل يعني، بس شوف التمبرتشر بدأت تتغير. خلينا أقول 20000. اوكي بدأت درجة الحرارة تتغير. زين هل بدأ ستريم يطلع عندي؟ لا ليه؟ لأن التمبرتشر وايد قليلة. اوكي التمبرتشر وايد قليلة، لكن لو أنا ضربت طبعا يكون دائما في الرينج 10 to the power 6 الكيو صح؟ So let me say yeah okay Amina, I'm sorry. Let's see what I want to do. I want to reduce the temperature so I can force the separation. So let me say I have something like 3E6. Okay. Okay. Look to the temperature, it has significantly changed. Okay, now it's 74. Look شباب to the liquid, the molar flow. The molar flow now I have a liquid as well I have a vapor. And do I have separation happen? Did the composition change? Look to the composition. Composition has changed. Okay, so the composition here is different. This is the mole fraction of this stream. When I cool now and it entered to the separator, you can see that the composition has changed. However, I want to have just the right Q. So I don't want to do it by trial and error like what I'm doing now. I'm doing it by trial and error. I'm keep changing this. Okay, I can keep changing this until I obtain the 2% in the 2% in the composition, because he told us that he wants the ethylene here to be 0.02. So you can see that it's now 0.147. So not happy, come back here and change it. Come here and change it. And then you'll make it, okay, not that, maybe 2.5. Maybe that will make it better. Sorry, 2.5, 10 to the power 6, E6. And then you'll go back and check again the composition. Is it 0.02? No, not yet. So you go back and change it. So I want this one to be done automatically. And here where we are going to use adjust to do for us this. Yeah, I'm going to show you this. No, I'm not going to adjust the composition. I'm going to adjust the cooling because the composition here is change. Okay, it's change according to the QC. But what is the information given to us? He told us, I want the ethylene present in the hydrogen stream, which is this one, should be less than or equal. Okay, less than or equal to 2%. Okay, you can write here or equal. فأنا أبي شنو؟ أبي حاجة داخل الهايسس. I want something inside HYSYS. I told it, hey, listen, I want to give you the 2% here, and I want you to adjust the Q such that you get for me 2% here. Okay, that's what we want to do. And in fact, well, okay, well, this is actually, okay, well, because it's already 100%. But yeah, let's make it simple. Okay, now what is that tool that will do for us this, شباب? عندنا شباب tool اسمها adjust. The adjust is that thing that will do for us this one. Now, before that, we want the 2% that you see here. Let me write it here. The 2% that we are having here, I have the feed and I have the hydrogen stream. Okay, so that's the feed and this is the hydrogen stream. Okay, and the 2% that you see here, the 2% or the 0.02 that you see here is basically the amount, the flow rate, okay, the flow rate of hydrogen. So the flow of hydrogen in the feed minus the flow of hydrogen in this stream, Asif, the flow of ethylene. Okay, what is ethylene? Yeah, C2. The C2H4 in feed minus the flow of C2H4 in hydrogen stream, this one, in H2 stream, over the flow اللي هو نفسه دي C2H4 in feed. This is the 0.2%. This is the 0.02%. Okay, we're gonna call this the loss, basically. We're gonna call this the loss of ethylene. ليش? Because I want the ethylene to be in the bottom. So if ethylene goes to the hydrogen stream in the top, معناته أنا قاعد أخسره. Now look here, when I have this Q as 0, when I have a Q, when the Q? Yeah, when I have a Q, مساعة, I have everything up, I have nothing down. I have everything up, I have nothing down. So the loss is 1%, sorry, it's 100%. Because I have all my ethylene lost in the top stream. I will repeat. When all the ethylene, because you can see here I have zero flow. Can you see here? The molar flow equals 0 kilogram mole per hour. So I have nothing goes to the bottom stream. Okay, all the ethylene that supposed to be in the bottom stream went to the top stream or the hydrogen stream. So I have 100% lost. So that the loss is my parameter that I need to target. So that 2% is that loss. زين أنا شلون أسوي الكالكوليشن دي؟ I need the spreadsheet. Okay, so the spreadsheet مثل الإكسل. Okay, so this is a bottom here called the spreadsheet. And in the spreadsheet, when you double click and you go to the spreadsheet, عندك هني مثل الإكسل. So that calculation that you have seen me write it here, I can write it inside. Okay, the first column you can use it just for comment. Okay, تكتب whatever عشان أعرف أنا شنو دخلت هني مثل الإكسل بالضبط. Okay, it's like even Excel. Let me show you here what I do. لو أنا مثلا هني I want to add, for example, x1 and x2. Okay. Okay, so I can write anything here. Okay, I can write variable 1, for example, variable 2, variable 2. بعدين أكتب القيم مال مني 3 or 5. And then I can do operation here. So I can tell him now C4 plus C3 plus C4, C3 plus C4, صح? So wait on it. So let's say this is C, so I'm here tell him C3 plus C4. But this is just tag. It's like a tag. It tell you what is this and what is this. Because this might be temperature, this might be pressure. But the numbers are here. نفس الفكرة الحين بستخدمني. Okay. So here I'm telling him that whatever I'm going to write here is this is the ethylene. This is the ethylene in the feed. This is the ethylene in the feed. And this is the ethylene in the H2 stream. So this is just a text to tell me what I'm writing here. طيب الحين شلون اروح حط بالك شباب what I'm going to say now is important. شلون اقول له اللي في B1 is the ethylene in the phase. You have to right click. You have to right click and then add variable. فبيقول لك select import for cell. يعني you want to import something to the cell. فمن اللي انا بحطه هني ابي احط المولر فلو ريت مال الايثيلين في الفيد. So I'm going to go to the feed and then I'm going to go to the molar flow. كاني اسوي attachment. Okay, I'm attach. اسوي attachment للستريم هذه at that particular variable. Okay. عاد وين الحين ذي؟ يا الله. Okay, so that's one. The master composition molar flow rate ابي الايثيلين واقول له select. Okay. فتشوف هني عباره عن feed dot master composition molar flow rate مال الايثيلين. اقول له done. خلاص شوف حتى جاب لك القيمه مالته. If you double click on this بتشوف ان الايثيلين الستريم كله 1000 لكن الكومبوزيشن مال الايثيلين كم؟ 0.25. فانت تضرب 0.25 في 1000 في 1000 فيعطيك 250. So this is the value that has been imported from here to here. نفس الشيء في الموضوع دي. Right click, add import variable. هذه الهيدروجين ستريم نفس الشيء ابي منه البتاع. ابي من شنو الفلو وينه؟ الله لا تقربني. يلا ethylene select done. اوكي شفنا في شيء غلط. انا شنو سويت هني؟ right click edit import variable. سويت شيء غلط؟ احد يقول لي سويت شيء غلط. انا ما ابي الهيدروجين ستريم، انا ابي separated stream صح؟ ابي لتحت، ابي لتحت شباب. انا اسف شباب، انا كنت هني اقصد not the hydrogen stream, the bottom stream. Yeah, the bottom stream. Okay, so here I mean the separated stream, the one in the bottom. Okay, so that is the separated stream. The separated stream. ليش؟ لأن لو أنا عندي في separated stream 0 أوكي، وعندي هني ال 250 minus 0 250 على 250 100%، معناتها أنا عندي 100% lost. It means that everything went to the top stream. Yeah, that has to be not the liquid separated stream. Okay, the liquid separated stream. ليش صاير كذي؟ Let me close it. Do it again. Edit imported variable. I want the liquid separated stream master composition flow ethylene. Select. Yeah, now it's correct. It has to be 0%. طيب الحين اللوست اللي انا بيه اقدر اكتب المعادله مالته مثل الاكسل. 0 open bracket close it, and now I'm going to write B1 minus B2 over B1. Sort calculation. And this is like 100%. It's 1. Okay? So that is 100% divided by 100, which is 1. هذه الرقم هو اللي أنا أبي. This is the number which I want it to be 0.02. Okay, that's the loss that I'm looking for. But can you see that the spreadsheet allow me to introduce this relationship? Okay, the spreadsheet is what use this relationship. Now this formula موجودة داخل spreadsheet. Now I'm going to bring the adjust. So what I'm going to do نحين في adjust. Look here now, the adjust. The adjust, I need to adjust the variable Q. Okay, because I was doing this by trial and error صح؟ لا الحين لا أبي أقول له QC the heat flow selected, and that will be my adjusted variable. The target variable, the thing that you have to achieve, is that if you go to the spreadsheet, okay, the formula B3 اللي أنا سميتها lost. Okay, معاي انت؟ Okay, هني شوفها ال B3 lost. ال B3 اللي هي القيمة ذي 1. Okay, it's sitting in B3. فباي هني قلت له this is the Q, and inside the spreadsheet الobject اسمه SPRD SHT-1. البيك هذه هو التارجت B3. شوفها يابا. I want this target value to be 0.02. Everyone follow? Everyone follow شباب؟ قاعد أقول له أنت adjust. I want you to adjust for me this Q. شوف حتى شو بصفيه شوف. على طول سوى connection with that. I want you to keep adjusting for me that. However, you have to do that while your eye is on B3. And I want you to keep adjusting this QC until this B3 is equal to 0.02. Okay? Good. Now, when you go to the parameter, you will see that he's using certain method. And that method called secant. Where did we see this word before? Anyone can remind me? Where did we see the secant? Numerical. Thank you. So anyone can guess what this guy he will try to do? He will try to do iteration. Most likely, can you tell me the problem that he's trying to? Yes, Ali Shakrallah. That's the answer that I'm looking for. So what I have just explained in words is a root finding problem that HYSYS is going to solve. And HYSYS is going to use the secant method to do that. See, now you know what's happening. You are connecting the numerical analysis course with what we did in the beginning of the computer application, and you now see HYSYS is doing the same. Okay, now you can see that there is a tolerance here اللي هو تذكرون الايرور ما كان يقول while the error is greater than 1 exponential minus 4. Remember that? That is the tolerance. That's the tolerance. It's there. Okay. There is also a step size. يعني for an iteration to be equal, you keep it like this or you change it, doesn't matter. And there is that maximum number of iteration. So it's like he's using like for loop. He's using for loop. So let's make this one something like big, like 1000. Okay, like it's 1000 iteration. And now we press the start. Okay, now when you press start, you will see that he might not solve it yet. Okay, so maybe he need to do more iteration. So we're going to reset this. Now we'll not change this. We'll keep the default value. Yeah, sometimes because if the number of iterations, maybe I have to change the step size. لحظة بس. Let's make it, I don't know, like calorie per hours. So I don't know if that one. Yeah, because he does not شو اسمه ما قاعد يستخدم while قاعد يستخدم for. Yeah, see, you have to keep resetting this value until it's converged. Okay, so you really have to keep doing this until. Okay, guys, you have to keep resetting this until you got the solution. Now let's see what we got here. So the adjust now مفروض طلع لنا Q. Okay, well the step size يعني بتسرع الcalculation, but even if you don't know it, you have to keep resetting this until until you got a solution. لأن أنت you are solving a nonlinear problems فهو ساعات stuck at local minimum. Okay, we'll come to this details بشوي. But for now, let's see did we achieve our target? Did we achieve our target? مفروض احنا الحين composition مالنا composition here مالنا يكون مثل ما احنا نبي. Okay, and there is something wrong here. That's 400. That's 599. But when you look at the composition, what? Something crazy going on here. Well, let me just delete that guy again. نعم بابا. Yeah, I muted myself. Just a minute, I want to check something. اوكي ما اعرف ليش في اوبشن ما قاعد يطلع لي نفس مساعة when I select غريبة. Okay, what I will do, let me save it and open it again عشان ما أسوي مرة ثانية. بس before that I'll delete the adjust. Let me save it as in the desktop. Just save it. I need to close this. هاي الفليد الفلوريت ما أدري ليش ما قاعد يطلع لي المفروض هني on the right يطلع لي في الفيد which composition I'm talking about. ما قاعد يطلع. I don't know why. طيب anyway شباب عشان الوقت ما يضيع هو في شيء weird هني من ساعة يمكن شفتوه انتو when I came to here. Okay, well what if I bring another adjust? When I came here, when I select the feed and I select في الفيد يعطيني الماستر. كان في شيء اسمه master here. I don't see it now. I click on what? I click on that. بس ما يطلع على طول يطلع لك ذي في ماستر بعدين داخله حصل الايثيلين بس ما اعرف ليش ما قاعد يطلع الحين for some reason which I don't know what. ف لأن ليش مفروض أنا هني يعني تشوف هني when I import variable see تشوف هاي selected تشوف هذه ما قاعد يطلع لي في ال adjust because when you come here and you select the master okay I have to اختار الايثيلين فيطلع لي selected here. المفروض اني في الادجست يطلع نفسه ما قاعد يطلع بس ساعات طلع بس الحين ما قاعد اشوفه for some reason I don't see it now. I don't know why. شوف اختار الفيد يطلع لي هني what exactly I'm looking for. I cannot find it بس ساعات طلع بس الحين ما قاعد يطلع. غريبة. طيب maybe I have to delete everything and do it again. but الفكرة شباب هي في شيء weird صار عشان تجي بعد الكومبوزيشن صار أكبر من واحد for some reason I don't know why. بس هو واضح إني ما أعرف في bug صاير. في bug صاير. No, I don't want to delete that. What about do you wish to delete it? Yes. Because if I no the spreadsheet is okay. Spreadsheet is okay. بس إن يعني شوف الإيثيلين in the feed that's the variable I need. That's the variable which I need to yeah see that's the variable when you need where you need to import. بس when I حط له just for some reason ما قاعد يجيبه. see I select the feed شوف ما يطلع ما أعرف ليش. Okay guys, ما أعرف شنو صار. أنا عدتها مرة ثانية, but now as you can see, a Q has been calculated here, which is that amount. Okay, and if you go to the hydrogen stream and you look at the ethylene composition, you will see that the ethylene composition is less than 2%, less than 2%. And also, if you look at the problem, they told us also that the mole fraction of hydrogen in the separated, اللي هو bottom stream, has also to be less than 0.02%. And if you go and look at the hydrogen, you will see that it's less than 0.02%. So the objective of this exercise here, two things. First of all, إذا معلومات is not enough given to us, like here we haven't given the for the cooler to be solved, عندي يكون عندي شنو؟ يكون عندي either the temperature, the actual temperature, or the Q. طبعا المسائل القبلية مثل ما قلنا we don't have the Q, so we given the temperature such that we can calculate the Q. So here we don't have this, okay? عشان كذا I assume it's 0, but that 0 of a Q or whatever number for a Q you put does not achieve your objective. And what is your objective? Your objective that you do have something here, mainly the composition of the ethylene in the in this stream, which is this stream. Well, خلينا الحين نحط الcomposition اللي نشوفه كامل. Okay. Okay. So the composition of the ethylene, okay, in the H2 stream has to be less than 0.02%. Has to be less than 0.02% as given here. Okay, and that is satisfied. And for that to be achieved, there is like a specific Q that need to be specified for this stream here for you to get this number. And I don't know what is this number, and that's why I use the adjust to achieve for me this target. Okay, so this is like a goal seek mal Excel. And for this, as you can see, all what you have to do is that you attach the adjusted variable, which is in this problem turned out to be Q. And then the target variable is your target. What is your target? What do you want to do? I want this one, for example, to be equal to 0.02. Fine. Now, why I'm telling you this? I'm telling you this because now we want to solve, remember our problem here, this one. When I start solve this problem, I told you that R1 is equal to, sorry, the conversion of methane in reaction 1 is 87%, and the conversion of methane in the second reaction is 13%. 13%. So if I don't give you this two number, how can we solve this problem? Anyone can tell me how can I combine adjust and a spreadsheet and the adjust and the spreadsheet in order to solve this problem if the conversion of methane in the first and the second reaction are not given to us? أحد ممكن يقول لي شلون؟ Anyone can tell me how can I do that? No, but I can put any number. Okay, what I mean is, okay, let's try quickly. يعني if أنا start المسألة دي مرة ثانية, so file a new case. Okay, so I'm going to start solving this problem. without having the exact 8713 because I don't know them. Okay, so when you start solving this problem you will okay من الأول طبعا المسألة بتكون عندك الميثين. Okay, like methane and the four component here, just carbon, mono, and yeah, and hydrogen, and water. Okay, هاي الأربعة. بعدين الفلويد package. I'm going to add pink, and then the reaction. Add reaction, reaction 1, conversion, add reaction, close it, double click. So I have methane, water, carbon dioxide, and hydrogen. And I have here minus 1, 1, 1, 3. صح؟ Okay, now look here. هني أنا ما أعرف كم. أنا ما أعرف كم الكربون monoxide. يعني أنا بساعة I know it's 87, but now I don't know how much. I have no clue. So I might say this is for example 40. ما أعرف كم لا. Okay, فبحط 40. I will add the other reaction. I will add the other reaction. Close this. And the other reaction will have 60 because قال لي إنه 1%. قال لي إنه 1%. So I have 2 hydrogen صح? Plus carbon dioxide and sorry. Methane ما في water? Yeah, water. Okay, ما تدخل تغيرهم. So I have the methane minus 1 وعندي الماء minus 2 وعندي الهيدروجين 4 وعندي الكربون dioxide 1. Okay, so that's 0. And the conversion of methane here لأني حطيت مساحة 40, I'll put 60% here. But I don't know whether these are correct or not. I don't know whether this is correct or not. زين شلون بعرف هو correct أو لا؟ إذا أنت تيجي تحل when you come and solve the problem بتشوف الcheck مالك is this. The 17.4% is your check. So if the conversion is correct, لأن الconversion له علاقة ال 17.4% له علاقة بالcarbon monoxide, which mainly comes from the first reaction. Okay, so let's خليني أرويكم. خلينا نحط the temperature. So the temperature is 600 Kelvin. The pressure is 1 atmos. And the molar flow is 100 kilogram mole per hour. Yeah. وطبعا عندي الكومبوزيشن هني ميثين والباقي كله صفر صح؟ Yeah. And then I have another stream. Which is the steam. نفس الحرارة 600 Kelvin والpressure 1 atmos والmolar flow rate 200 المرة. Yeah. And that is mainly water. I normalize, and that should be the steam. Yeah. And then I go to the reactor. I have my reactor here. Attached to it the methane and the steam, and I have vapor, and I have liquid, and I want a Q of reaction to be calculated such that the stream is having an outlet temperature of alpha 30 Kelvin. Okay, so the problem solved. The problem solved, شباب. لكن the problem solved based on the information that I provided here. Mainly the reaction has a conversion. التفاعل الأول 40%, التفاعل الثاني 60%. But with 40-60%, what is the carbon monoxide composition? What is the carbon monoxide condition? Can't you the composition here? Oh sorry, الستيم ما دخلته. أنا ما دخلت الستيم على الرياكتور. Okay. Okay. So it's a vapor phase reaction. Everything is up, nothing down. So look here شباب على الميثان totally converted. وعندي carbon monoxide وhydrogen وcarbon dioxide وwater as given to us in the output from البتاع. Okay. Now, what is the carbon monoxide composition? It has to be 17.4%, يعني 0.174. What is it here? It is 0.08. It's 0.08. معناته ان الكونفرجن مو صحيح اللي عندي. فانت بتي تقول اوكي then what I have to do معناته لازم اغير الكونفرجن مالي. فبتي تقول انا معناته الرياكشن الاول اللي عندي maybe I have maybe 60%. اوكي. والرياكشن الثاني هو 40%. عكست يعني. And then you will say, okay, the problem solved, and now you will come and see what is the carbon monoxide? It's 0.12. Well, this is still not 0.174. معناتها أنا بعد لازم أغير الconversion. So I come here again and I change the reaction 1, and then I will put the conversion maybe 65%. And if it's 65%, معناتها reaction 2 has 35%. ما حاب يقعد يسوي هاللون صح؟ And then you see things get improved شوي. Okay, can I use what we did right now مساعد بشوي to solve this problem? Anyone can conceptually tell me how we can do this? We use adjust. How? How شباب? I have two things here. I don't have one thing. فشنو أسوي؟ How to use adjust? I use adjust. لاحظ adjust need only one thing. يعني adjust شباب adjust require only one وين adjust? Okay. Adjust شباب when you use adjust has one adjusted variable. زين انت عندك two adjusted variables. So how can we do this? Okay, so the second will be 1 minus x. Add to adjust? No, but they are linked, Ali. But I think what Nariman says is correct. So we have one is x and the other one is 100 minus x. But Nariman, how then يعني انت لو قلتي هذه x, okay, so if I have here x, so he will keep adjusting this until he gets that number, and then in the spreadsheet the other variable اللي هي 100 minus x will be changed, but it has not been exported to the reactor. يعني هو يعدل, he will keep changing this, he will keep changing the conversion here. And the other conversion has been calculated inside the spreadsheet, but I didn't send it here. يعني لازم أنا أطرشها لهني بعد، صح نريمان؟ فاهم شو أنا أقول؟ Yes, so I need after the calculation happened in the spreadsheet, after the information happened in the spreadsheet, I have kind of export the variable back to the reactor. So how can I do this? Maybe the calculated value, okay, maybe when you come to the spreadsheet and you calculated the 100 minus x, maybe there is a way to export the formula result. Can you see, guys, here? Maybe there is a way to export the 100 minus x thing back to the reactor. Okay, I'll keep you guys try this yourself. أنا يعني تقريبا قلت لكم شو تسوون. And inshallah, next lecture I will ask you, what did you do? Okay, so what I did today, I was explaining the idea of a spread and adjust with yani, using two different examples here. So you now have a feeling what this adjust spreadsheet can do for us. So we can use them to achieve a certain goal by adjusting one variable while achieving a specific target. And that's basically what happened for root finding a problem. So if I have something like x cubed plus 3x plus 2 equals 0, what do you do? How I use adjust for this? And if I want to use adjust to solve this root finding problem, okay, شنو بقول له؟ بقول له my adjusted variable is what? If I want him to, شلون ما يكتب بعد؟ كل شيء تعب خلاص. لا ما صار يكتب. كل شيء تعب. If I want to use adjust to solve this problem, شباب. So I will tell adjust what? Adjust for me x. Adjust for me x بالضبط. And what is the target? The target is the right-hand side. The right-hand side equals 0. بالضبط. So that's exactly what adjust do. فبتجد adjust assume values for x, assume value for x, assume value for x. ليه ما كل مرة عقب طبعا once it assume value of x, it will calculate this value تشوفها صفر لا مو بصفر. Will suggest another value of x. صفر لا صفر لا ليه ما يخليك صفر. That's what adjust do. نفس الفكرة عندنا هون. It's the same idea. Which part? Which last part? علي ما فهمت. Which last part? قصدك الموديل مال المساعة؟ الموديل مال المساعة مال الهيدروجين والميثين؟ بعد ما فهمت قصدك. يعني how to use the adjust you mean؟ ولا هني مالت مساعة اللي وانا ما حصلت الفاريبل ولا؟ قصدك الرياكتور example ولا الاكزامبل مال مساعة السيبريتر والكولر؟ شنو اللي هاي ما سويت adjust انا للحين. I'm asking you to do it. I am asking you to do it adjust for this example. I want you somehow to utilize this too, such that Yeah, such that you adjust the two conversion molar reactors. Okay guys, أنا خلاص تعبت. We'll start from here إن شاء الله next lecture. الكويز جاهزين بس ما أعرف ليش ما طرشتم لكم. عندي إياهم جاهزين إن شاء الله. كويز نمبر 3 للحين ما جهز. التست إن شاء الله قبل تاريخ 3 بعطيكم إياه قبل الدروب. I'll give you. كويز 2 جاهزين. المفروض قلت بحطهم في الهاي بس شوي كنت مو بصاحي. بس بإذن الله maybe in this weekend I'll send it to you guys. Okay guys, thank you very much. Have a good day.